Hi everyone, welcome to our video on line applications. Now, with all word problems in math, we just want to make sure that we're reading everything clearly and like drawing pictures when needed and making sure to label the variables correctly with our x's and y's. So on these applications, I don't think we need any type of picture, but we'll still make sure to label everything correctly and read it very carefully, even though there might not be much going on sometimes, like this is only one line, but still read it carefully and make sure that it is fully understood. So let's break this one down. So in 1997, there were 8,000 residents in Ladybug City. In 2013, there were 10,000 residents in Ladybug City. Write an equation in slope-intercept form, that should be form, for the number of residents in Ladybug City after 1997. Okay, so whenever you have these types of word problems that have time involved, okay, so they're giving us dates, and it's after 1997, that's also important. So whenever they give us time is most often associated with x. So that's going to be our x variable in this problem. And then the other information, which looks like it's involving an amount of people, the residents, that will be our y. So let's put number of residents represents y. Okay, so the after part, let's actually highlight that. And I'll just kind of do a big pink star there. Whenever they say after whatever date, they're trying to state that that year is when your x value should be 0. Okay, so instead of using time as 1997, you could do that, but this is usually easier to work with. So for instance, if 1997, our initial year date, is x equals 0, then that makes it easy to convert 2013. Okay, so 2013, well, it looks like it's 16 years after 1997, so that would be 16th then. Okay, so what we're doing is really breaking it down to get points. So let's take this information, the 1997 is x equals 0, and make a point out of it. Okay, so for our let's just still mark it like this. So 1997, we have the time is 0, and then they're saying the number of residents in 1997 is 8,000. Okay, so our x-coordinate again is the time, the y-coordinate is the number of residents. And then for 2013, they're saying the x should be 16 and our y-coordinates is 10,000. So that's the number of people. So there we go. So we have 2 points is what we're doing, is what we've got. So this is so I wrote it a little high, but this is our x1, y1, and this is our x2, y2. So we have our 2 points. And then that way, for number 1, they're saying write an equation in slope-intercept form for the number of residents in the city. So all they're asking for, so find an equation, they're saying find the line equation. And whenever we need to find a line equation, we always need our slope and we need a point. Well, we already do have the points. We do have the points 0, 8,000 for x1, y1. And then we just need the point, or we need the slope. So to get the slope, well, we can make a quick sketch. So we have 0 and 8,000, let's say, is about there. We'll just leave it completely blank. And then 16 and 10,000, we'll say, is somewhere up there. So this is not to scale, but we can see there's our line equation like that. Okay, and then we could use our slope equation. M is equal to y2 minus y1 over x2 minus x1 to finish off getting that slope for what we marked as number 1 over there. Okay, so let's plug these in. So y2 is 10,000 minus y1, which is 8,000, over x2 is 16 minus x1 is 0. And so 10,000 minus 8,000 is 2,000. And then 16 minus 0 is 16. Okay, so we have 2,000 divided by 16. Let's go ahead and assume that we are going to use a calculator on this. Often with applications we do. So I'm just going to divide it real quick on my computer calculator, and it gets 125. Okay, so our slope is 125. Actually, let me just kind of leave that blank there. So we have our slope right here is 125. And notice it is positive, which matches the upward the upward movement of the line. Okay, so we have our slope and we have our points, and then now we can do our y minus y1 equation equals m times x1 or x minus x1. Okay, so this is our point slope form of the line, and then we'll plug those in. So we've got y minus y1, which is 8,000, equals the slope of 125, x minus 0. And then now we can distribute the 125, and we'll have y minus 8,000 equals 125x, because 125 times 0 we don't need to write. And then in one last step, if we add the 8,000 over, we'll get our line equation that they wanted. Okay, so then that is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So just to mark it, so there's our slope-intercept form, and then this one was the point slope. Point slope form. Okay, so there it is. So we got our equation. And then in step 2, they're asking, when will the town have a population of 14,000 residents? Well, that's where we just go back to what we said. What does the residence variable stand for? Well, the residence is y. Okay, so that means we'll go use 14,000 and plug it into our equation right here. Okay, so we're just making sure to use the correct value for the correct letter. So we'll plug it in. We have 14,000 equals 125x plus 8,000. And so we need to solve for x. So we'll minus the 8,000 over. And that will give us 6,000. And then now we can divide by 125. And that will give us x all by itself. Okay, so back to the calculator. Let's go ahead and just clear. Okay, so 6,000 divided by 125 is 48. Okay, so we've got 48 like that. Okay, so but we need to make sure that we have the correct answer in the correct form. So what this 48 means currently is this is 48 years after their initial year that they wrote about, the 1997. Okay, so there's that. Or we could do the addition like we did to figure out what 16 was and say, well, 1997 plus that 48, that would give us the calendar year. Okay, so we'd have 5, 4, 2045 is what it looks like. Okay, so 45 years after 1997, or if they want it back into like a calendar year, we could say in 2045. Okay, so there's different forms, but the main thing is making sure we understand what this 48 does represent. It's the 48 years after 1997. Okay, or again, whatever actual calendar year from some side addition work. Okay, so that's how we can break these down. Okay, so the main thing is really just, I would say kind of over here, just getting those initial setups. And then from there, it's what we've been doing when it wasn't word problems, just finding the equation of a line, making sure we know line equations, making sure we know how to get slope. Okay, so let's see one other example. So in this one, it says the total cost for a bakery to produce 50 blueberry muffins is $40, while the cost to produce 100 blueberry muffins is $75. All right, find and interpret the slope of the cost line for the blueberry muffins. All right, well, let's break these down and figure out what we've got. Okay, so so it says the total cost for a bakery to produce 50 blueberry muffins, and we also have 100 blueberry muffins. It looks like that should be our X. Again, most typically, so there's certain things that we can catch on to. Most typically, the dollar amount, a dollar amount is going to be involving Y. Well, let me just do the symbol. So the dollar symbol. Okay, so usually Y is some type of dollar amount. Just like how X is usually some type of time, like in the previous problem. Okay, so whereas X in this problem is the number of blueberry muffins. I'm just going to abbreviate it and say muffins. Okay, so we have the dollar amount. Let me do the two. There we go. Dollar amount for Y, number of muffins for X. And, well, what we can do is, again, just write these out as points. Okay, so we've got our 50 blueberry muffins is $40. So here's 50, 40. So that's our number of muffins. That's our dollar amount. And then we also have 100 and 75, like that. Okay, so these are our X1, Y1, and X2, Y2. And they want us to find and interpret the slope of the cost line for the blueberry muffin. So all they want is the slope in this equation, or in this part. So let's go ahead and use our slope equation. So our slope is Y2 minus Y1 over X2 minus X1. And from there, we could plug those in. So we have 75 minus 40 over X2 is 100 minus X1 is 50. All right, so 75 minus 40 is 35. 100 minus 50 is 50. And then this does reduce. 35 divided by 5 is 7. And 50 divided by 5 is 10. Okay, so that reduces. Okay, and so what we've got from here, so we need to interpret it. Well, it goes back to what's important about our X and our Y's. So let me color code it. So Y is the dollar amount. So this is $7. And actually, let me put that. That looks kind of weird at that point with it to the side. It's kind of the wrong spot. So this is $7. And then the division would be per. And then these are the number of muffins. So that would be 10 muffins. Okay, so it costs $7 to produce 10 muffins is what that is saying. However, even at this point, because it's a word problem, we would probably change it into a decimal. So 7 over 10 becomes 0.7. And then at that point, we can say, well, this is 70 cents per muffin. Okay, so that's how much it costs. Let me go ahead and put it. So they said interpret the slope of the cost line. So it costs 70 cents per muffin. Okay, so that's what that means. So the slope is kind of showing it as an average for this scenario. So the slope is showing an average right now. Okay, and then let's continue working with our slope and figure out what else they want. So on the part 2, determine an equation that models the data. Write the equation in slope-intercept form. Okay, so we're finding the equation of a line. We have the slope. Let's go ahead and do the decimal. And we do have a point. Let's do the 50 and 40. So there's our x1 and y1. And we have our equation, the y minus y1 equals m times x minus x1. And then we can plug all that in. So y minus 40 equals the slope. Let's go ahead and do our decimal 0.7, x minus 50. Okay, and then even with the decimal, it still works the same way where we distribute. So the 0.7 would distribute. So we'd have y minus 40 equals 0.7x minus, okay, so I'm using my calculator again. Let's just do 50 times 0.7, which gives us 35. Okay, so we have minus 35. And then now let's add the 40 over to both sides. And that will give us our y by itself equal to 0.7x plus 5. Okay, so there we go. So this is the equation that models the data. Again, the y is the cost in dollars, the x is the number of muffins. So from there you can plug in whatever values you want to figure out the cost. Okay, and then one other, and we can also check it, like if we plug in 50 and 40, it should work out. And if we plug in 175, it should work out just fine. Okay, so let's see number 3, where we've got use the answer from above to determine an approximation of the cost of 150 blueberry muffins. Okay, so again, we just want to make sure, well, this is saying use x equals 150. So we'll use this equation. So y equals 0.7, but change the x into 150 plus 5. And so let's use our calculator one more time. So I've got 0.7 times 150, which gives us 105. And then we'll need to add 5 to it, which gives us 110. Okay, and so that's the cost. Remember, y is a dollar amount, so it looks like it cost $110 for 150 muffins. And that's it. Okay, so the main thing with these word problems is really just, I would say again, just quickly, like in the blue and the purple of these problems, is to mark down what the variables should be. And then from there, it's all is just what we were doing in the previous types of videos, where we're breaking down our slope equation and slope line and plugging things in and being careful of signs and all that. Okay, so anyway, I hope that helps. If you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.